At Xarkin, we make motion. Xarkin Motion is a patent-pending platform for the automated generation of physics-based motion, simulation, and control for articulated assemblies. Whether you're an animation studio creating 3D character motion, a game studio creating motion for playing and non-playing characters in a video game, a programmer moving characters in a virtual space, or a programmer wanting to move a robot, the Xarkin Motion Platform can create improved motion in less time at less cost. We'll be showing 7 key features and capabilities of the Xarkin Motion Platform. Xarkin Server generates motion through the use of universal models. Xarkin develops a universal foundation agent for every supported topology, from humanoids and quadrupeds to dinobirds. From this foundation, we create universal motion models respecting the specific constraints and range of motion for that character class. Motion models can be cyclic for repeated movements such as walks, runs, and jogs. Acyclic models are for single motions such as rising from a crouch position. This model was extracted from third-party pose data using Xarkin Motion Extract. We used a reverse modifier in Xarkin Motion script to return the character to a crouch. Xarkin models are universal. We'll show what this means. We applied a simple walk model to these 3 characters. The resulting pose data accurately reflects each character's physiology, incorporating their mass profile when provided. The clip here shows 3 very different characters, all walking for 10 strides. Each completes the task at a unique pace and distance, all while maintaining perfect surface contact. Xarkin's universal motion models automate retargeting. Surface contact is accurate. Timing is automatically adjusted. Xarkin simulation and physics creates accurate motion for each character's physiology. Having universal motion models is only useful if you have models for creating the motion you require. A second key capability is Xarkin Motion Extract, which can extract, model, and correct motion from existing motion assets. Xarkin provides a standard set of fully parameterized motion models such as the run shown previously. These models support many common motions. Xarkin also develops custom models to meet specific customer requirements. An example would be this pirouette motion. Let's slow it down. The placement of the arms and hands and the number of turns are parameterized options with this model. However, there is a multitude of motion possibilities, and you may have existing motion assets through direct keyframe manipulation, motion capture, and so on. Xarkin Motion Extract is designed to process these assets in order to create universal motion models. These modeled assets can now be applied to other characters and can be parameterized to extend their capabilities. Motion Extract will also correct motion if required, ensuring proper surface contact and balance. Finally, Motion Extract will generate required metadata for use in the Xarkin Motion Design Editor. The Xarkin Motion Design Editor can be used to edit any motion model in order to modify the model or create new ones. Xarkin motion models can be opened in the Motion Design Editor. The Motion Design Editor serves 2 main purposes. It can be used to modify existing models, either to change the model or to create a new one. It can also be used to code Xarkin Motion Script. Motion Script is a markup language processed by the Xarkin Motion Server to generate pose data. The Motion Design Editor runs in a browser. We can load a motion model on the stage from a library, or we can use Motion Script to generate pose data which we can then edit. Once loaded, we can play this walk as a single cycle of 2 strides. Since this motion repeats, we can also play this as a sequence of 5 walk cycles of 10 strides. We can adjust this walk to lengthen the stride and slow the pace at the same time. Once we update, we see the character is now taking longer, slower strides. We have control over the parts of the armature. We'll make the character look right by making an adjustment to the head motion using the Z-axis. This just scratches the surface of the editor's capabilities. Parameterized motion models and Xarkin Motion Script will take this much further. When models are parameterized, the motion generation possibilities are greatly expanded. A motion element is a specific use of a motion model with a set of parameter settings that determine the pose data that is generated. To show this, we'll start with a motion model that generates pose data for a walk. The character on the left shows a typical walk. However, I would prefer that there was more separation between the feet. A simple script change, and now we have what we are after. I might also want longer, slower strides. Again, with some simple changes to the script, we now show exactly this. Finally, I was hoping the character could look to their right. We'll make an adjustment to the head yaw, and now we have what we are after. A single model provides countless possibilities. The motion shown here was all generated using Xarkin Motion Script. Motion Script is a markup language processed by the Xarkin Motion server to generate pose data. Motion elements are specific uses of parameterized motion models. With Motion Script, we modify these parameters to get the specific motion we're seeking. However, not all motion possibilities are simply a sequence of motion elements. Motion modifiers allow us to apply specific motion changes that span different motion elements. We combine motion elements and modifiers to create motion sequences. If we diagram a specific sequence, we can see how these might interact to create a desired outcome. We start with our character standing from a crouch. With a minimal transition, they perform a walk for 2 cycles, 4 strides. The connective frames making up the transition are automatically generated by the Xarkin Motion server. Through a longer transition, our character moves into a run for 3 cycles. This might not be all we are after. We might want the character to look left, spanning from the walk to the first run cycle. Our character might be going up an incline for a few steps, or they could change direction over a number of steps. Motion Script provides animators, motion designers, and programmers with granular control of the articulated assembly they are moving. When connecting one motion element to another, a transition needs to occur. A transition provides the connective frames between different motion elements. These connective frames are automatically generated by the Xarkin Motion server. Animators and programmers control the transition that occurs through Motion Script. A transition would occur when moving from a walk to a run. Here, with a step count of 2 steps, the character quickly transitions to a run. We'll compare this with the same character with a step count of 6 steps. Let's view this a bit slower. We can see that the 2-step transition jumps to a run, whereas the second character takes 6 steps to build to a run. There are multiple transition options that a programmer or animator can choose. As demonstrated, the step count provides complete control of the number of steps used in the transition. A minimal setting tells the motion server to use as few frames as possible to connect the 2 motion elements. An auto setting tells the motion server to automatically create a transition. When moving from one motion element to another, there are cases where the ideal transition is to modify part of the first motion element. For example, a character walking onto a narrow beam may require adjusting the foot separation of the first element. The backward transition parameter can be used to do this. None is also an option when a transition is not required. Transition generation and the previous key capabilities all rely on the Xarkin Motion server. The Xarkin Motion server provides physics-based motion, simulation, and control for articulated assemblies. Creating motion starts with posting a motion request. Each request will provide a motion script that tells the server what to do. In addition, it contains the mapping profile and, optionally, a mass profile for the character. Environment variables such as gravity are also included. Finally, it includes the current motion context, which is needed to effectively transition to the motion requested in the motion script. By default, Xarkin's Cloud Motion Services runs the motion server. There are other options. Xarkin works with customers to support bespoke deployments of Xarkin Motion Server and tools integration. Xarkin Motion Server can run on customer cloud infrastructure, servers, edge devices, and can also be deployed as local software. Once the motion request is received, the motion server will generate the required motion. Next, this generated pose data will be processed through the simulator. This will identify the necessary corrections that need to be made for the specific character. Finally, using the simulator output, we will apply physics to the pose data, providing physically accurate motion with proper balance and surface contact. The Xarkin server sends the response containing the pose data back to the client application. Xarkin Motion Server's highly efficient proprietary algorithms for generating physics-based pose data support real-time motion generation. Xarkin optimized these algorithms to run on minimal hardware. These algorithms automatically compute force and torque data for articulated assemblies. Let's review the Xarkin Motion Platform. Universal motion models allow us to retarget and generate motion to a broad base of characters sharing the same topology. In addition to Xarkin's standard motion models, animators and programmers can use motion extract to convert existing motion assets into modeled assets that can be applied to other characters. The motion design editor can be used to alter motion models to create new motion possibilities. Models can be parameterized, greatly expanding the range of motion possibilities for a given model. MotionScript provides a markup language for constructing motion sequences made up of motion elements and motion modifiers. Motion elements are specific uses of parameterized motion models. Xarkin Motion Server uses transition parameters to generate the connective frames between the different motions in a motion sequence. Central to all of these capabilities is the Xarkin Motion Server software, receiving requests and returning pose data. The Motion Server can be run in the cloud, on servers, edge devices, or as local software. For animators and programmers, the Xarkin Motion Platform provides improved physics-based motion possibilities in less time at less cost, engineered motion with limitless possibilities. If you're interested in learning more about the Xarkin Motion Platform, please contact us using the form on our website. Xarkin thanks Mixamo for the use of their 3D characters.